So the probability that two things that happen, two events. The first one, 3 was expected. So the probability that 3 will be gotten will be 1/6 for the first one. For the second one too, same 3. That'll be 3, that'll be 1/6 too. So this probability. So multiply. So this probability that even E and even F will happen. That's it. Yeah. So running the die twice, each outcome is an order pair of results, like 4 on the first row and 1 on the second row. But event is restrict only the first row to 3, having no effect on the second row. Similarly, event F restrict only second row to 3, having no effect on the first row. That means they are independent of each other, but it's restricted. Note that if events probability E is not equal to 0 and probability F is not equal to 0, then the event E and F cannot be both mutually exclusive. Yeah, they can. Okay, E is not equal to 0. Okay. And independent. If E and F are independent, then probability of both E and F occur. Yes, if they're independent, it means like what I was telling you, this will be there for independence. But if it's mutually exclusive, it won't be there. Okay. So this is the formula actually. This is for independent, this is for mutually exclusive. Okay, now the meaning of independence is that we have P and E, the two events together, working at different, differently. So this is just try to understand this whole principle. Please. Now, let's move on. So this can only happen when there is independence. You understand? P or E and their independence, this is this. E or F, when they are mutually exclusive, it means this is 0. So you can have mutually exclusive and independent at the same time now. And let's continue with our example. If first 6-sided die is row 1, let E be the event for rolling 3 and F be the event for rolling odd numbers. Now, you know that 3 is an odd number. It's possible. Even if it's those ones, when they said it's those ones, not twice. Now, these events are not independent. This is because rolling a 3 makes certain that the event of rolling an odd number occur. So it's not independent. So it means that the answer will be probability of E and F is going to be 1/6 for E. For probability of E equals the probability of E 1/6, and probability of P and F together should be 1/6 times 1/2. Now, very simple. This first space is for 3, right? I have 3, which is probability for 3 to happen in that in 1 to 6. In 1 to 6 is just 1. This is 1/6. Now, multiply by probability for odd number. This is for the second space here, which is going to be 3/6. Odd number, that's 1, 2, 3. That's 3/6. That's what we have, 3/6, which is same as 1/2. For the first one, that 1/6 is for 3, probability of having 3, and it's chose 1. So they just have to multiply the two together, but they are not independent. Actually, they are not. So P of F is supposed to be independent, but they are not independent. But there's a way you can redefine it. So that means the answer will be 1/12. Calculate for probability for 3 first, probability for odd number first, then you multiply it together. Now, because I know this thing is getting a bit complex, and with the philosophy and all of that, but try to put your mind into it. It's something that you understand it. That's all. Now, another example, a 12-sided die with physics number 1 to 12 is to be ruled once, and each of the 12 possible outcomes is equally likely to occur. Probability of ruling 4 is 1 over 12. It should be 1 because if we list 1 to 12, this 1 to 12, and we are looking for the probability that the selected number will be 1. That will be this. We have only 1 for it. That will be 1 over 12, right? That is why we have 1 over 12. So probability of ruling a number that is not 4 is, now I told you earlier on that probability of having a number that is not 4. So that means you remove this. So probability of every other number but that is not 4, that will be 1, 2, 3. You skip 4, 5, 6, 7, 8, 9, 10, 11. That will be 11 over 12. That should be that. But now there's a shortcut because I told you initially that the total probability is 1. So since we already know the probability of 4 already, so that can be 1 minus the probability of 4. That will give us the answer, probability that is not 4. And now what they did here, as that is not 4 is 1 minus 1 over 12. This 1 over 12 is probability of 4. So this is just to help you with time, to save your time in your calculation. Can you see they got 11 over 12? The same thing I did when I counted it. You understand? So please. The probability of ruling a number that is either a multiple of 5 or 10 or an odd number is equal to a probability of multiple of 5. If you go back, multiple of 5 is 5, that is 1, 2, that's 2, that will be 2 over 12, right? That's multiple of 5, 2 over 12. Now, probability of odd number, let's go back. Odd number, this is 1, 2, 3, 4, 5, 6, that was 6 over 12. 6 over 12. Then, plus, I told you or means addition, that's why they're putting addition. Plus, now, probability of having multiple of 5 or 10 in the number. Now this formula I told you about, when you're looking at 2 events and or is there, look at this formula I give you here. Or means plus and means multiplication. So when we are talking about 2 events that has or, look at, for example, this one. This is the formula. PE plus PF minus PE and F. And this will work for if it is independent. If it is not independent, we are going to go for this second one, if they are mutually exclusive. That was why I wrote here that this is for independent and this for mutually exclusive, just to explain to you. But these are the 2 events. Now, since these 2 numbers are they didn't tell us that they are mutually exclusive. They did not tell us that. So we use the formula, this first formula, and this is minus probability of 5 and odd number, which is 1 over 12. Now, I think it's very, very important for me to explain that to you. Now, for the odd number, so we use this formula. Okay, so we're talking about or. I already told you event or. If you have C or, this is the formula you use. However, all the time you have to check if it's independent. That's when you use it, but because this is the what makes it independent. This particular P intersect F or P, E, and F. But if it's mutually exclusive, you remove this, you use the second one. Now, this one is obviously independent because they didn't even tell us if it's mutually exclusive. Now, if you use it, if you look for the multiple of 5, which is 2 over 12, like I showed you the other time, multiple of odd numbers is over 12. Now, for you to get this value, this P multiple of 5 and odd is the formula. So that would be probability of 5 and times probability of odd. And this is, let me show you in my book. P and F, because the probability of 5 is probability of odd. That gives you, when you multiply that with 12 over 14, I'm sorry, 12 over 144, you divide it, you have 1 over 12. So what they did here is that they multiply the probability of this and probability of this together. That will give you the answer to this, and that's what I did here. Probability of the first event, which is a multiple of 5. Second event to probability of odd number. You understand? And that gives you this. But to make it more clear, then put this 5. Multiple of 5 and odd number, and multiple of 5 and let me see, odd number, to make it more clear to you. So that's what we have here. So, and that's why they have this. So when you do it, you get 7 over 12. So you just have to understand it. You know the reason why we have this formula. If this formula now, if they told you in the question that it is mutually exclusive, you delete this. So you're going to have 2 over 12 plus 6 over 12. Because the interval is mutually exclusive, it means it is independent of each other. So you do it that way. You understand? So that's that. Let's move on. Another way to calculate probability rolling number is either okay. I think I've done that. Yes. So the answer is 12. Solve it in the formula. Consider an experiment with event A, B, and C, for which PA equals to this, PB, probability of B equals to this, and probability of C equals to this. Suppose that the event A and B are mutually exclusive, and event B and C are independent. What is the probability of P or B? P or C. Now, I told you this way they are going to test your knowledge of independent and mutually exclusive. They told you that A and B are mutually exclusive. It means that, when you have events and you have all day, I told you use this formula, right? Already. But because now it is now mutually exclusive, so we are going to pick this one instead, not the first one. PE plus PF. So in this case, for A and B, since they said they are mutually exclusive, so the probability of A or B will be probability of A plus probability of B, which equals to probability of A is 0.23, probability of B is 0.40, and that's the answer. But for the second one, B and C, they are independent. It means that the third value will be there. That means I'm going to use this first formula because they are independent, which means that since they are independent, it means P of B is independent, so that will be PB plus PC minus P to B and C. So this B and C is the same as probability of B times probability of C is B plus B plus B plus B, sorry, probability of B plus probability of C minus probability of B times probability of C. Now we have a probability of B 0.4, probability of C 0.85, which is in the question. Then you multiply the probability of 0.40 times 0.85, probability of B times probability of C, and that gives you the answer. So that's the difference between this question and the first question. Now, let's move on. Suppose that there is a number. Suppose that there is a number. Suppose that there is 6-sided die that is rotated in such a way that each time the die is rolled, the probability of rolling any of the numbers from 1 to 5 are all equal, but the probability of rolling a 6 is twice the probability of rolling a 1. When you roll the die once, the 6 outcomes are not exactly equally likely. Yeah, because the last one, which is its probability is twice. Now, what are the probability of the 6 outcomes? Probability of the 6 outcomes, you have to add everything together. Now, since there is, this is not common, but they are telling you that the last digit of 6-sided die has a double probability compared to the first, compared to 1, 2, 3, 4, 5, 6. So it means that This